Good morning. Welcome to the second session of the Climate and Data webinar series being hosted by the BC Agricultural Climate Adaptation Research Network. We're going to get started with a quick introduction to ACARN and to the series, and then we'll move into our presentations. People are still joining, so we'll just have this slow warm-up to get started. So I'm Shauna McKinnon, I'm the coordinator for ACARN, and it's a pleasure to be hosting this webinar today with our presenters from the Pacific Climate Impacts Consortium. Before I introduce the speakers, I'm just going to give a quick introduction to ACARN for those that aren't familiar with the network. The BC Agricultural Climate Adaptation Research Network formed 4 years ago in response to the need to increase collaboration and increase sharing of resources and expertise across institutions and across the province to better address the complex challenges of climate change impacts on agriculture. ACARN brings together government, industry, and academic researchers with 10 institutions represented on our steering committee. And it's the steering committee that guides the direction and the work of the network. Along with the steering committee, we have over 100 members across the province who are working in agriculture adaptation in research and policy and programming and extension. And many of these members got involved with ACARN through projects and events like this one today. Before we jump into today's webinar, I wanted to give a quick plug on an event taking place tomorrow. A number of members of ACARN are presenting on COVID-19 and what lessons can we learn to apply to climate change and be better prepared for climate change impacts in the agriculture food systems. So that's taking place tomorrow at 3 p.m. and it's hosted through UBC Land and Food Systems. It's a free webinar and I'll share the link for that in the chat in just a moment. So for our webinar series, our webinar today is part of a series of climate and weather data for BC agriculture adaptation. The reason why we are focusing on this is because it's really a cross-cutting issue for all climate change adaptation research. And the series is developed as a way to introduce people to the tools and data that are available and to have a chance to have your tough questions answered by experts themselves. So each session in the series provides a tour of different data and tools that are available. A couple of weeks ago, we had our first session, and that session is available. The recording for that is available on our website and on the ACARN YouTube channel. And we'll have a couple more sessions coming up in the fall. All of these sessions will be recorded and posted, and they're also going to be part of a new resource that we're developing that will be also available on our website. So for today, we will be exploring 2 climate modeling and analysis tools, Plan to Adapt and Climate Explorer. These have been developed by the Pacific Climate Impacts Consortium. And presenting today, we'll have Kari Tyler, who's the User Engagement and Training Specialist from PCIC. And joining her are James Hebert and Stephen Sobey, and they're going to be helping answer questions throughout the webinar. So for today, we're going to be using 3 features to keep things interactive. So I want to just introduce those now and give them a test so everyone's familiar with them. So the first thing that we'll be using is the Q&A box. So if you look at your interface, you should see a Q&A box maybe at the bottom of your screen. If you pop that open, you'll see that that's a place you can type in your questions. You can feel free to type in your questions as the presentation is going on. Stephen and James will have a chance to be answering those in real time. And then I also will be moderating a Q&A period following Kari's presentations where I'll be drawing from those questions you post there. We'll also be using the chat feature. So if you want to open your chat box now, that's a place where we can share general information to everyone and you can post comments as we go along as well. And then the third thing that we'll be using is the polling feature. And I will just pop up the first poll now. And you can fill that out and let us know where you're joining us from today. This is a great way to let our presenters know where you're coming from. If you happen to fall into the other category, you could use the chat box to give us a little more information on where you're joining from. Great. I'll just give you guys another minute to fill it out. But it looks like we have a great mix of participants today coming from quite a few different backgrounds. So make for good discussion and great questions, I hope. Great. Well, I'll end the poll now, and you can see the results there of who's joining us today. And Kari, I will let you get started.
All right. So I'm just going to start sharing my screen, and then I think I'll probably have to switch screens once. Yep, I'll just have to change the display settings. So there we go. Are you seeing my first slide, the title slide?
Yep, looks good.
Perfect. Okay. Thanks, Shauna, for the opportunity to do this presentation, and I'm really glad to see everyone who's joining, and I welcome people who are continuing to join this presentation. So I'll be doing a lot of the talking today. My name is Kari Tyler, but I'm joined by two colleagues, James Hebert and Stephen Sobey. And James is the lead of the computational support group at PCIC. So they're really the engine that makes these tools go. And Steve is here. He works on the same team as I do, the Regional Climate Impacts team, but unlike me, he is actually a climate scientist. I'm an adult educator by training and background. And so the first thing that I want to say to everyone on the presentation is please respect James and Stephen's time by asking questions. They're here to be resources as well. So please do ask questions in the Q&A, make comments in the chat, but really we're trying to kind of drive the question asking to the Q&A function. So I think most attendees can see that probably on the bottom of their Zoom panel. So check and make sure that works for you, and hopefully you will be able to participate by asking really good questions. So today what I'm going to be doing is a quick kind of introduction on climate data, as well as introducing Plan to Adapt and Climate Explorer. And I would like to encourage everyone to log on to Plan to Adapt or to the Climate Explorer and kind of test it yourself and play along. The other thing that I will say with that is I do encourage you to do that, and I will be showing screen grabs because I have had experience before of trying to do a live walkthrough while lots of other people are using the tool, and it can sometimes it can be slow, or sometimes my own internet can be slow. So please do check out the tools and feel free to be doing that during this presentation. In fact, I would actually encourage that because that could inform the kinds of questions that you ask and really make good use of our discussion time at the end. So please do open the tools and explore and be coming back to this Zoom webinar to ask your questions as you're going through that. So I just wanted to start with a quick reminder of a couple of concepts that you will have likely heard or seen before if you've attended a webinar or presentation that I or my colleague Trevor Murdoch have done. And one thing that I think you're probably familiar with and we talk about a lot is that climate varies by location and with time. So one of the things that we talk about in terms of an example that Trevor tells a story about being in Montreal in December, I don't actually remember what year it was, and phoning back to Victoria. And in one location, it was sunny and it was about 19 degrees out. In the other location, it was about 4 degrees and snowing. And when we do a live presentation, we can do a quick poll to ask people who thinks it was sunny and warm or in what location. And normally, it's just a guess because nobody actually remembers what the the weather was at a specific location at a specific time. And so that's just a guess. So one of the things to remember is that when we're talking about weather, it has that temporal and location specificity. And when we're talking about climate, we're talking about this aggregate, this larger clump. So this is an example then of climate. This is the planet in June, July, and August of 2003. And the planet as a whole at this point was about 0.4 degrees warmer than the historical baseline of 1970 to 2000. And you can see by looking at this heat map, BC is approximately where the star is, that BC was warmer than other places in the globe that summer. Europe was experiencing an even warmer than even warmer than the baseline summer, and that was a year where they were having really extreme heat waves. But there's also places that are cooler, like Japan. There is having a cooler than normal summer. And the main reminder here is that when we're talking about climate models themselves, build in both this temporal variability and spatial variability. And so when we're thinking about BC and we're thinking about how we move from the historical record to the future, we switch from a recorded weather to modeled climate. And keeping that in mind, the nature of climate models, which there's other webinars that can talk much more about the nature of climate models, and the gridded nature of the data is really important when you're using this data in an applied way for research. So this is where it's important to keep in mind, I'll say this probably a couple of times, it's important to keep in mind your own context and query kind of what you really want to be using the data for. And in terms of keeping your own context in mind, if you have a very specific location in mind, then one of the things that you need to be aware of, if it's, so agriculture is often in sort of valley bottoms, it's not often at high altitudes. And if you're thinking about gridded data, that's averaged over an area that could include elevation differences. So the more specific your question in terms of your research and what you want to be using climate data for, the better you actually need to understand where this data comes from, and the capacities and constraints to how you use it. So this is really just an introductory webinar, but I hope it's also an invitation for some of you to explore by trying to use some of these available tools, but also to learn more about them and about climate modeling and climate data if this is something that you're really going to be using and integrating into your work. So another sort of quick introduction, a reminder that when we're talking about future climate, we're talking about scenarios, and the tools that we're working with today work with the RCP 8.5, 4.5, and 2.6. And those correspond with RCP 8.5 with a high emission scenario and RCP 2.6 with a low emission scenario. And sort of in practice, these are sort of the outer bounds of probable, like not possible, who knows what humans are capable of, but this is sort of standard practices working with these, and I think the easiest way to think of them is the bounds of probable. Now, one of the things also to be keeping in mind is, again, basic statistics. And again, you have that one of the functions of climate models is to capture not site-specific historical climate, but this pale gray zone there is actually the modeled past. The black line is in fact the historical climate record. And the modeled past corresponds with the historical record, but you'll also notice that the historical record has peaks and valleys that kind of stick out on the edge of the modeled past. And that is fine. The models are still accurate and useful, but that's a thing to keep in mind that if you're comparing, that it's really not best practice to be comparing station data to climate model data because of the conflation of that, particularly the spatial variability. If you want to do a deep dive into those questions, I'm going to kind of push that into later. And the main point that I'm going to make right now is just that what climate models do well is capturing the historical, both temporal and spatial variability in BC. And that if we keep thinking about that over the course of the future, and when you're using your data, keep in mind that we're talking about, for a lot of this, we're talking about averages, so that there will be tails on either side. That will be a wider range. So that's why it's important to be looking at the data that's available in terms of also understanding the range. And as we go into the tools, be attentive to where and how range shows up with those as well. Another point is that Plan to Adapt actually uses RCP 8.5. And that's because Plan to Adapt is our more user-friendly tool, and really what it comes down to is RCP 8.5 is the emission scenario that most of our users are using. It's most commonly in use. And part of the reason for that is because RCP 8.5 in the 2050s is equivalent, is an equivalent amount of climate change to RCP 4.5 in about the 2070s, which is what we're kind of highlighting in this image here. And in the shorter term, the differences between the different RCPs are quite minor. So it doesn't really matter if you're just looking at the 2020s. So just a reminder as we're getting into the tools, to really encourage you to explore them, to play around with them, like play around with me, or hopefully you've got another window open in a browser and you're kind of checking these out and you're thinking about the questions that you have for how you'd like to use climate data and what the capacities of these tools are. In using climate data and in trying to figure out how to use it to inform research or to inform decision making, it's really important to understand your context sort of physically, and it's also important to understand your process context. And so the point about heuristics and reality here is that often what people ask me for is climate data that they can use with an existing model or an existing tool. And if that tool has been designed based on an assumption of a static climate, conceptually, future climate doesn't fit well because there's this range of possibility. And of course that brings with it uncertainty, but you really need to explore that, what those uncertainties mean. So just notice when you're using heuristics, really understand the value of them and sort of interrogate them a little bit and think about if there's a different process or a different tool or that you can use that might be a better way of capturing the range of possibility for future climate. Always, again, one of the big things that we learn in any sector once we start talking about climate change is the importance of breaking down silos and building diverse teams with diverse perspectives and getting some creativity and alternate perspectives in on looking at the data and looking at these issues. Again, with looking at the data, if there's questions or variables that you're looking at, I always recommend that you visualize it multiple ways. Again, this is an option in the tool, and check variables that maybe aren't your primary inquiry. It's really important if you have a question about temperature to also understand what's happening with precipitation, because it may be that there's a really interesting looking seasonal change in precipitation that might affect why you want to be using your temperature data. So that's also about being willing to learn and reframe your inquiry and to work with the available data. So with that, I'm going to go into a really quick introduction to Plan to Adapt. Main points about Plan to Adapt is it's the more user-friendly, sorry, here we go. It's more user-friendly than Climate Explorer, and the way that it's more user-friendly is that we whittled down some of the options. This is a kind of tool that's been designed kind of with the idea in mind, if you have 5 minutes or 7 minutes to understand something about climate change in your region, this will give you results that have meaning and that will hopefully open up a bunch of questions. This isn't a tool that's going to like answer all of your questions. This is going to give you some insights that you then build on and sort of inquire more deeply. So it's got defined regions that are regional districts, health authorities, and eco provinces. You can choose from your time periods, the 2020s, 2050s, and 2080s. So I just did a screenshot of the summary, summary page, which is where you land when you get into Plan to Adapt. I happen to select the Kootenay boundary region in the 2050s, and this is the summary sheet that we see. One of the things that might be, this is a really quick and easy way to get changes in growing degree days, changes in average annual temperature, tells you stuff about changes in snowfall, also frost-free days. And you can look at some of these changes as maps. So here again, this is the Kootenay boundary, and this one I chose annual frost-free days. And here we've got some projected change that you can look at. And again, the other way that we can look at things is by graph. So here I've picked a different variable. This is temperature and in the spring. And note here that this is change from baseline. So this isn't what the absolute temperature is. This is the change in temperature over these time periods. And this is, of course, bounded here. So just a quick recap of the variables that are available. There's frost-free days, growing degree days. You guys can figure that one out. All of that, those variables are available. I think all of them are available both, yes, they are all available seasonally and annually, and you can get the maps and graphs of all of those. So this is an exciting thing. Plan to Adapt has just been fully kind of rebuilt from the ground up behind the scenes, and hopefully this will make it easier to update, but it certainly syncs much better now with Climate Explorer. So this is my reminder. If you have questions, particularly about Plan to Adapt at this point, please do put them in the Q&A box. If they're, and James and Steve can be reviewing them and answering them if possible, or we'll come back to them at the end to spur some larger discussion. So now I'm going to go on to Climate Explorer. I noticed a typo, of course, now. Climate Explorer is for more experienced climate data users than Plan to Adapt. This is much more of a like choose your own adventure tool. You can define your own region. You can specify different climate models. You can choose between different RCPs. So in using Climate Explorer, this is what I was trying to set up at the beginning. You have to make the most of it, you really have to understand what climate models are and how to work with climate data. Don't let that scare you though. There's a lot that you can do with it by sort of exploring and getting into it. There's a lot of different variables that are available, and the thing that Climate Explorer does have that Plan to Adapt doesn't is it has much more extreme indices. And that's often quite useful for people. Best practice when you're using climate data is to be drawing from ensembles. And so Climate Explorer, the data that I'm going to show is stuff that has been calculated with ensembles, and I'll talk about why that's important. This does show the values and change from data. The data is downloadable. There are some videos, some introductory videos available on the Climate Explorer landing page, excuse me, that you can check out. And I've also included in the references another webinar that I did exploring more about extreme precipitation in partnership with FP Innovations. All right, so going into Climate Explorer, again, these are all screenshots. If you go in and play along, I think often your visual range will be bigger than what is showing on the screen, but I do encourage you to go identify an area. You can choose your own area. You can draw it as a rectangle, or you can draw your own polygon. Pick your model. There's a drop down there with a lot of different options. Again, my recommendation is to be working with an ensemble. So we do have PCIC 12 as an ensemble available. It simplifies your calculations. Otherwise, you should be comparing the results of multiple models together for any sort of analysis. And so if you're looking at variables that don't have an ensemble calculation, then you really do want to be downloading data from multiple models and sort of a spread of the model context, and comparing all of those and doing your calculations. Add sort of another step of calculations. So here I'm looking at a comparison between a historical baseline and RCP 8.5 for precipitation. Here we go. So here I've sort of picked a rectangle in the northeast of BC out by Fort St. John. And I'm looking at just precipitation. So this is average precipitation. So this is a variable where you've got your seasonal variability in the annual cycle. And if you hover over any of the particular dots on this graph, you get sort of the monthly mean, the seasonal means, and the yearly mean values as well. So that can be quite useful. So here's the model context, which is another one of the tabs. So this is the PCIC 12. This is the ensemble run. So here you see the model context as this blue line right up the middle, which is the point of an ensemble. This also shows you with the individual models the range of values that they have. And this is the point where if you're picking individual models, you want to pick models that sort of represent, that capture that range of values for whichever variable you're looking at, to get accurate may not be the best word, but to get a more whole picture of what the possibility of your climate future is. So if you have questions about why picking a range of models, I may toss that to some of my colleagues, but I know that it's important, again, because as I was mentioning, one of the things to be understanding with future climate is the range of possibilities for the future. So also here with precipitation, if you change, there's another tab, right? We're just going along left to right on the data graphs. You can get the change from baseline. This can be quite useful. Again, we're looking at the northeast here. So part of what we're noticing is from baseline, there's a change in an increase in precipitation in June and a decrease over some of the summer months as we go through the century. So again, this is color coded. So this gives you climatologies for these 30-year periods. You've got the 2020s in orange, the 2050s in green, and the 2080s in red there. And then there's also underneath a statistical summary. Again, you can get this data and export it. This is what captures the range. Again, in this page, so you can get it for time of year, monthly, or annually. I'm actually not sure off the top of my head if there's seasonal subcategories here with the download. It may depend on variable as well. But in looking at the graph, it's also important to be checking this statistical summary out, again, because it gives you a little bit more information about the range. It also gives you multiple baselines to compare, which is a functionality in Climate Explorer that, of course, doesn't exist, excuse me, in Plan to Adapt. But you may choose to do a comparison with a more current baseline. I have this one set to, in this case, it's 1971 to 2000. So the last thing I wanted to talk about in my sort of very rapid run through tools is we have a bunch of variables available on Climate Explorer with return periods. So they are the variables that start with RP number. So this one is 20-year annual maximum daily maximum temperature. And what this actually means, and I had to confirm it again. So what this is this is the maximum daily temperature that has a probability of occurrence of 5% in any given year. So this is kind of an annual, this is calculated annually. There's not seasonal variation on this. Of course, it's fair to assume that when it comes to annual maximum daily temperature, you're not actually going to see that in November and December. But that's why when we go to this change from baseline, all those values there that describe the change from baseline from the 1971 to 2000 in the 2020s, the 2050s, and the 2080s, those values are correct, but there's not the like regional specificity to this one. So I'm bringing this up in part because, well, we may change this display going forward, but with some of the extreme variables, you do have to give some thought to what some of them mean, and then what data you can extract from that and how you might actually look at that. So I would suggest that you, if you're not right now, check out Climate Explorer and look at the list of the 46 different variables that are available there. And if there's ones that you're interested in where you don't know what they mean, and this would be a good time to get some clarification get some clarification on that. And also there's someone else who would love to know that information. Be very confident that that would be a useful question. So I will acknowledge that I have gone through this very quickly. And in fact, that was on purpose, because what I really am hoping that you're able to do, and hoping that you have been doing, is kind of exploring these online tools as I've been talking at you. And I am noticing that some more questions are coming up, and I really am hoping that you have a lot of questions and are thinking about what data you would like, and that you have questions about how we might be able to get at it, or that you're looking at Climate Explorer, and you have questions about what you're seeing and how to use it. And with that, I think I am going to step back from the talking. I do questions. This is my final reminder to ask questions. And I do just have some few further viewing recommendations. For those fundamentals of climate change, Trevor and I did a video series some period of time ago. Was it just a year, Shauna, or was it longer?
It was just over a year ago.
Just over a year ago. Everything in the before time seems very far away right now that we're working from home and dealing with a pandemic. And there was also a webinar with FP Innovations that was done with support from Flynn Road. That's also on a Flynn Road website. You can find a link to it through that. So I think that is it from me for now, and I'm gonna turn it over and encourage people to be spurring some discussion.
Great, thank you so much, Kari. Well, we could start, there were some technical questions on Plan to Adapt that we could start with, and then we can shift to some of the questions that are coming through on Climate Explorer. So maybe if it's easier for you to stop your screen sharing, Kari, we could do that as well.
Yep.
So on Plan to Adapt, there were a couple questions on both resolution, what is the resolution of the data, and how large or small of an area could you use for that analysis? Can you do something that's sub-regional, for example? And I'm not sure which of you would like to take that question, but James, Steve, you can also unmute yourselves and answer if you'd like.
I can start, and then I'll watch for you guys to unmute yourselves, and then I will stop. But when it comes to Plan to Adapt, the regions are defined. So it's a defined region. If you want to, that's where the information for Plan to Adapt is for your whole regional district, averaged over that whole area. So that was part of the reason I was beating that dead horse, or maybe I wasn't, about averages and being aware of your physical context and where you were in the outlined gridded area. So to choose your own area and to get like, in Climate Explorer, you can go down to a specific grid cell, and I will ask James or Steve to tell me how big a grid cell is on Climate Explorer, because I admit I do not know.
Yeah, hi, Kari. So a grid cell on both is 1/12 degree, which is about 10 kilometers by 10 kilometers, more or less. depends with latitude, but roughly 10 kilometers.
Okay.
There's also a question on further research going on for Plan to Adapt, and I know that this is a brand new version of Plan to Adapt. So do you want to just speak for a minute to what changes have happened between the two versions and how these are being adjusted over time?
I'm going to pass that off to James because I think he has a lot more insight into the whole history. I've just come to PCIC in the last year and a half and Plan to Adapt. I don't even remember when the first version came out, but I think it was almost 10 years ago. So James.
Yeah, I can speak to that a little bit. Yeah, I think that the first version of Plan to Adapt came out in 2011, if I recall correctly. So it's been about 9 years. So the changes that have happened between the last version and this version, basically we rewrote everything from the ground up, and we're using the CMIP5 data. The classic version of Plan to Adapt use CMIP3 data. So Plan to Adapt now gets all of its data from the Climate Explorer. But yeah, we completely rewrote the user interface. We rewrote the impacts engine. I don't know what you mean as far as whether there's research going into Plan to Adapt. There's definitely still development going on. But I think the intent for the coming year is to work with researchers to kind of rewrite what the rules are for the climate impacts. So I think Kari didn't go over the impacts engine for Plan to Adapt, but basically it has an expert system that was developed by researchers in different areas. And so it kind of looks at the region, looks at all the different variables there, and then tries to project what some of the plausible impacts of climate change will be on that region. So we'll be taking a look at those over the coming year with panels from different areas of expertise and revising those.
Great, thanks for that. Before we move into a couple of questions on Climate Explorer, I do just want to throw up a quick poll here because I'm curious, and it would be helpful for our presenters to know how many people that have joined the call today have used Plan to Adapt before, and do you think you would use this tool? There is a maybe option, so you can be on the fence about whether or not you would use it in the future. Yeah, so that's great to see that there are a lot of people who are brand new to using it and haven't used Plan to Adapt in the past. I'll just give you another minute here.
And I think as well, with Plan to Adapt, if you have sort of questions or comments on it or sort of suggestions for how things could be framed on the site, feel free also to send me an email or sort of open up a conversation about that.
Yeah, that's great. Thank you for the offer, Kari. That's part of the point of the webinar series, is also for people to know where to go for more information. Yeah, so it's good to see that this is definitely a tool that people would like to use. And I'm just going to put up the same thing on the Climate Explorer, and then we could get into some of the specific questions on that tool.
We have one question on the Q&A that I think I'd maybe like for Steve to possibly answer or reframe. The question is, what is the margin of error on climate change modeling tools? And I think there's maybe a way to answer that.
Yeah, I can give that a shot. So margin of error is kind of I could refer to a few different things, I guess. So it depends what you are considering. So what variable, in general, there is greater confidence in temperature or thermodynamic variables when simulated by climate models compared to things like circulation. So and in precipitation, there's more uncertainty in things like precipitation compared to temperature, because you have sort of a noisier signal. It's a noise issue basically with precipitation compared to temperature. So it depends on what you're looking at. In some cases, you can get very good agreement in terms of historical simulations with climate models. In some cases, you may see greater differences. And it can depend on what climate model you're using as well. Some are designed differently than others. Some do better at different things. And so it's not a one uniform answer. It really depends on what you're looking at to really determine what a margin of error is.
And another question that we have on Climate Explorer is what the change from the baseline is. What are you using as the baseline for that tool?
I actually can't answer that off the top of my head, but I will answer it once I figure it out.
So I'm just going to share from the second poll about Climate Explorer. So very few people on the call or on the webinar today have used Climate Explorer before. So, and it looks like people are definitely interested in using it in the future. On the past webinar that we did, there were a lot of questions around how to access and download data. And if people have specific questions about how they would use it in their own work, this is a good chance to answer them. If you don't want to type out your answer, you could also raise your hand and I can unmute you. You could ask it directly. We have until 11:30 today for the webinar, so we do have plenty of time for questions. So another question through the chat is, what is spatial temporal resolution? What spatial temporal resolution are you using? And are there climate models that are using a higher emission scenario than 8.5? I don't know, James or Steve, do you want to tackle that one?
Yeah, so the resolution with all of the Plan to Adapt and the Climate Explorer are both the same at 1/12 degrees, or roughly 10 kilometers by 10 kilometers. So they're all the same grid in the way that you see them in these tools. So they've been statistically downscaled from whatever resolution they were originally in their native climate model format. In terms of higher scenarios, they exist, but they're not usually used by the majority of climate models because there are questions about how you would achieve even higher emissions, especially towards the end of the 21st century. So the RCP 8.5 is already a upper level or higher emission scenario as you get to the end of the 21st century. And so it's generally considered as high as sort of is reasonable. But again, it depends on what particular economic population various pathways are followed. So there's descriptions of them if you're interested in understanding how they are chosen. But generally that's the most frequently high level emission scenario that's used.
Thanks, Steve. Going back to the margin of error, so various models handle these and have more or less margin of error than others. And so there's a question about which climate change modeling tools appear to have less margin of error than others.
Yeah, so I guess in general, that's why we suggest using the ensemble. So what Kari was mentioning is that way you use a set of climate models that you would expect based on the differences in design and natural variability that occurs will give you a better representation than any one model in general. So again, it depends precisely on what you are looking at, what variable, what aspect of precipitation, and where. But that's, again, why we encourage the ensemble, because that way you average out some of the individual nature of the climate models and generally get a better representation than if you were to pick any one model at random.
And I'll chime in a bit too in terms of thinking about like accuracy or correctness of climate model and climate tools. The biggest sources of uncertainty are about sort of global human behavior in terms of what our future emissions will look like. And so I think in sort of wrapping your head around some of those sources of uncertainty, or in thinking about, you know, which model might be better, or which pathway should I choose, the reason that we keep emphasizing the ensemble and understanding that range of possibility is that the fundamental challenge with climate change is that our future is going to be different from the past. The future is different from the present. The present is different from the past. We've been experiencing changes, and those changes will continue, and they may continue in the same ways, and then there will be some interesting sort of nuance and variability to those things. I mean, we know that warming is going to happen, but how that plays out at different scales depends on things sort of beyond anyone's control. So I think that's one of the things to be keeping in mind with climate models and sort of questions about. I think sometimes some of the questions that drive at what is the right answer is sort of to understand that it's about understanding the tools that we have to kind of illuminate the range of possibility. And then we might have to, in interpreting those tools, we might have to develop different processes that are more resilient and adaptive and responsive to change our own behavior or change our decision making, so that each side of that possibility can be accommodated. So I don't know if that answered or sort of addressed more about that question, or just kind of went sideways, but I think one of the biggest challenges in climate change is thinking about just how much change is occurring, and how many different ways our assumptions about how we make decisions and what processes we use will have to change as a result.
Thanks, Kari. There's another question on precipitation. So could you explain further about the extreme precipitation information that's on Climate Explorer? Anyone want to tackle that one?
I think I could try and answer that. There's a variety of variables that are available. Precipitation, right off the bat, you can just use that. I think there's also a few precipitation return period variables. So those are the variables that show what the maximum amount of precipitation would be on a 20-year return period, 50-year return period, and I can't remember what we use, but so there's that. And then there's a variety of extreme climate indices referred to as ClimDex. So those are, I'd have to look, but yeah, there are probably 3 or 4 ClimDex variables that describe certain types of extreme precipitation. And that might be the maximum 1-day rainfall, the maximum 5-day rainfall, total precipitation over the course of the year. So those are all available. We can kind of explore and find them.
Great. And also related to precipitation, is there more uncertainty around precipitation data than other variables?
Yeah, so it's more like a signal to noise issue, is that precipitation is generally more noisy. So the year-to-year variability is generally higher than temperature. And especially as you go out into the future, you need a much bigger signal to sort of see it outside the noise in terms of precipitation than you do for temperature. So it's just, you can see particularly in projections of extremes, they start to show up. But there's definitely more uncertainty associated with precipitation than there is for temperature, and especially as you get to finer scales and resolutions. I mean, if you can imagine any rainstorm, you know that places very close to each other can receive very different rainfall amounts, and so that's a real uncertainty contributor as well, just trying to capture the really detailed differences in spatial variability adds to the uncertainty as well.
Great, thanks for that answer. Do others have questions they want to ask? You can raise your hand or type it into the Q&A box. Hani, I had a question around tools to give scenarios to adapt to climate change. Hani, would you like to raise your hand and you could ask that question directly? Maybe give a little more description of what you're looking for there. You should be able to unmute now.
Hello. They have. Okay, I'm not sure if.
We can hear you. Oh, now we can't, if you're speaking.
Do you want to ask your question just with a little more detail? What you're looking for?
Hi, can you hear me?
Yeah, we can hear you.
Oh.
So you're looking for, are you looking for?
I can guess maybe, and Hania, you can try. If your audio is not working, you can just sort of.
I'm not sure if I can be heard now.
Yes, now we can hear you.
Oh, okay, sorry. I don't know what's the problem. Okay, so I was telling that currently I'm working on flood risk management, and I wanted to know how I can use this tool for like developing some scenarios for like adapting to climate change, specifically for the impacts on flood management. So do you think this can be useful tool for me as well for this research?
Yeah, I think it's a useful contribution. I mean, one of the things to be aware of when it comes to like doing adaptation planning is that like adaptation planning is always local and contextual. So it depends on the resources and capacities of whatever group is your target audience. So that isn't something an external tool can ever really provide. But one of the things that this tool can provide some insight to might be changes in extreme precipitation in your region. An important thing to be checking in your region also is understanding what kind of watershed. I mean, if you're doing flood modeling, you understand your watershed and whether it's rain dominant or snow dominant. Working with Climate Explorer might tell you more about changes in snowpack and points at which the watershed might shift from a snow to rain dominant watershed. There's also other tools available that are hydrological tools in the PCIC data portal that you might want to explore if you're familiar with working with hydrological data. I have like zero expertise on those, but our hydrological team works on them. And I don't know if any of our colleagues are on this now, but Plan to Adapt and Climate Explorer are ways of providing information to sort of start a discussion about climate impacts. So this is climate data is one step. It's the very first step, and climate impacts are derived from an exploratory process that is like talking to people and thinking to say, when with this climate data that I'm looking at that tells me the possibilities of how climate will change under these variables that are available, what does that mean for issues that I'm concerned about? So what does this mean for possibility of flooding? It can only tell you so much. It doesn't talk about soil. It doesn't talk about the shape of riverbeds, but that's all stuff that you know and can get somewhere else, and you bring these pieces of information together. So yeah, anyway, I think it might be useful, but it's certainly something that you have to weave in with a lot of other information tools.
Great. Well, if we don't have any more questions, we can wrap up now. So I just shared a couple links in the chat. One is the link to register for the webinar tomorrow, talking about lessons learned from COVID on climate change adaptation in agriculture. And then I also shared a link which is to the bcacorn.com website, where you can find the recording from our first session webinar, and also the recording from this webinar will be posted there as well. And I will email you that link as well once those are posted. And I hope you will join us again in the fall when we have our next sessions in this series. Thank you everyone for joining today, and thank you Kari, James, and Steve for joining from PCIC and sharing your deep knowledge on these climate modeling and analysis tools. And just the last thing is, if you have further questions or feedback, feel free to get in touch. And when you sign out, you will link directly to a 1-minute survey. Really helpful if you can give your feedback on today, as well as your suggestions for future topics we should focus on. Yeah, so thanks everyone.
Great, thank you all.
Thanks a lot, everyone.